Let's get started. A couple of things first. 50 years ago today, the first message was sent across what became the internet. However, the message was sent from UCLA to Stanford, and after the first two characters, the network crashed. The second thing is, I've been recording lectures that occasionally there's some noise, which I haven't been able to figure out where it's coming from, and so parts of the lectures get cut off because it's like just this loud buzz. I may just start using the microphone on the machine instead of having a headset. But so if you look at past the lectures on the audio and some of it cut off, that's why. It's like all of a sudden, like. So any questions? No one has any questions? Does that mean I can pull exam out and get it over with today?
So for coupling, we don't have.
Correct.
There's module coupling, and then also that chapter is object. Is that right? Is that
We didn't talk about the object coupling section. Yeah. Unless you really want me to.
No, you said you were responsible for the whole chapter, so I was just the part of the chapter.
Right, right.
And then also on the test, since we're using previous tests as kind of a gauge,
right.
Is there anything that was new this semester decided to test on just general topics that?
Yeah, I really haven't covered anything new this semester. I mean, yeah, yes. On the website, yes.
What pattern has this purpose? I think not only one, several patterns.
So the question is, when I ask the question about what pattern does this or satisfies this, there could be more than one answer. There are times, right? You know, what pattern reduces coupling? Well, there's several. I have in recent times specified give one pattern that does. Because in the past, I get people wrote 3 patterns and 2 were right and 1 was wrong, and then I'm supposed to ignore the one that's wrong, or I'm supposed to select which one. I mean, and what if 2 are wrong and 1's right? But okay, that one's right, and ignore it. So.
But a 10-point question is.
That sort of depends on the question, and.
It's like just pick a pattern, right?
Right, yeah. I mean, if you pick a pattern, if you explain something, right, then there's room for.
For answers where we have to pick a pattern, obviously the gang of 4 patterns are all, but things like object recursion or pattern, types filters, derivatives or patterns, just concepts.
Yeah, most of them we talked about a pattern, like Python filters is a separate pattern. It's just not in the gang of 4. Object recursion is just recursion is not really a pattern.
Well, that was covered in cases where chain of responsibility doesn't exactly fit.
Right, yeah,
Doesn't
yeah,
exactly fit,
yeah.
but you use either of those patterns.
Again, it depends on what the exact question is, but
Yeah, but you wouldn't want to see recursion as the answer for a
right, correct.
command processor.
Those are patterns, right? Dependency injection. Is that a pattern? It's a good question. I mean, it's just basically calling a setter method, right, or a constructor. I really don't consider it a pattern, but some people might. I haven't seen it discussed as a pattern, just as a.
Substitution. Labor the composite where leaf object, does that violate the list?
Okay, so the question isn't, can we use the composite pattern to satisfy that, but in the pattern itself, does it satisfy the Liskov principle? Basically, you want Liskov says that the child classes should be able to use wherever the parent can be used, right? And the problem with the composite pattern is that the leaf ones are different than the parent, right? In the sense that the parent is a container, whereas the leaf ones are not. So yeah, no, it does not, right?
It does or
It does not, right?
it doesn't?
It does violate, yeah.
Okay, okay.
Yeah. I mean,
Sometimes there are questions when A is not that cannot be used or that usually like we can the A
if the word is can, then it doesn't mean it has to be, but it might be used.
One of the questions on null pattern, null audit, null audit pattern slide. But some
So the question is a null object pattern used? The other question is, would we ever have a null object represent the iterator? And if the collection is empty, right, then we could.
Yeah, that was one of the I can ask you about because there's a null iterator where I saw
Yeah.
but there's a null iterator that's always is that a null?
Yeah, yeah.
Remove operations composite. How do we use mean, how do we think on it?
So the question is, in the composite pattern, we have to worry about adding the components, right? And you're saying if we move it up to the composite, how do we do security? Well, the issue is, what happens when you call an add method on a leaf object, right? Right. So we have to ask ourselves in the composite pattern, where do the add methods go, right? And if we add them only in the container side, then we don't have to worry about ever calling add on a leaf object, right? And so that's the security we're talking about, is we never are going to call an add method where it's not appropriate, right? We're not going to call add component to a button, for example. If we add it to the parent class, right, now what happens, right? Now our button class is going to inherit from that, right? And then on a button, we can call add. But then what happens when we call add component to a button? Well, yeah, right. And so then what happens, right? Well, we have no idea what happens, right? When you call add component on a button.
So with global coupling, the terminology in the book on the slides is kind of wacky. So basically, you're talking about the least being reference to a method. Then the difference between, obviously constants are better, but then are they talking about primitives versus data structures that are constant, or what do they mean by, they call it like an item versus internals of the data structure? I forget exactly how they call it. In modern, the distinction between what I interpreted as primitive constants versus data structure.
Well, when they talk about constants, they're not talking about just primitive data types, but it could be any data structure which is fixed, constant.
But there are two levels of constants. I forget how they worded it. One was reference to a constant, and another one was a reference to a kernel data structure.
Right. So one is just you've got an object, right, and its internal state is fixed. You can't change it, and we can send messages to it and get responses back, right? The second one is, we can actually, again, everything's constant, but we can then, ask, give me your name, right? Give me your address object, and it's constant too, but then we can interact with its internal data structure. So that's the difference.
And it's worse because that if you're just getting a constant that's an integer, you can count on that integer. If you're getting a data structure, maybe name goes away, maybe the data type of name changes, because that's why.
Well, again, yes, but when your example is you're saying that in the first case we're talking about an integer, we may not be talking about an integer, right? We could be talking about some object that has an internal data structure, but all we can do is access this public interface.
Versus a custom data structure.
Well, as opposed to having an object where we can say, give me, this thing that's part of your internal state. Now, again, we can collapse that into what you were saying as well. Having the constant being an integer, okay, that's one thing, or we can have a data structure, right? We can access it, but in the object setting, the more general context is, well, there's a thing over there, and we can send it messages, whether it's an integer or it's a foo object, right? And then on this side, oh, again, we can send it messages, and one of them gives us its internal state, or part of its internal state.
Question, I'm not sure. Are state objects, can state objects be shared?
And so your question is, well, the first question, what does it mean, right? So example. So we got a web page, right? And you have to log in, and so there's not things you can do when you're not logged in, and when you're logged in, certain things you can do, and maybe even if you're logged in as an administrator or as a regular user, right? You have different levels, and so we can then use, if you're using a state pattern on the website, depending on which, we get different states, right? And of course, you may have multiple people connecting at the same time, right? And so the question then becomes, can we have it such that, we only have got one non-logged in state object and one regular user state object and one administrative state object. And then if we've got 5 users logged in, we're using the same state object for all 5 of them. And then we have to ask the question, does your state object actually hold state or not? Does that hold any data? If it doesn't hold any data, right, then sure, we can share it because there's no, if there's no data inside of it, then having 1 copy or 5 copies is, they're all identical, right? And so if your state objects have no data or state inside, then yes, we can share them.
Is that where the terms intrinsic state and extrinsic?
No. That's with a flyweight pattern.
Yeah, I know. Intrinsic state is stored by the object, and extrinsic state is passed in. Or are you saying those?
Well, the state pattern, saying there's no data in there, it may need data at some point, right? So where did the data come from? Well, the client that's using, or they always call it context in that pattern, right? That's using the state pattern, they've got the data. When they want something done, they're going to call a method on the state object, and they just pass in the required data, right? Which could be a reference to yourself, and then the state pattern grabs the data out and does something. No. Well, there's one instance where it was a motivating an idea, right? And so the question, what was that idea? let's see, one was passing off responsibility when you can to others. And then I recall this.
We're doing work with responsibility. I guess it's the same.
Yeah, the same thing, right? Yeah.
The second
Yeah, but I believe I only used one Dilbert cartoon to motivate it.
But yeah, if you must accept it, you can pass it to someone else.
Yeah, yeah. Hmm.
and a virtual.
Well, the the command doesn't make an object later, right? It performs an operation later, whereas a virtual proxy, um, pretend it did the operation and will do it on demand. Um, so you might say, yeah, the virtual proxy um, only executes the operation when it's actually needed.
Question?
Structure's the same, right? In that, in both cases, you're wrapping in. You,
Very similar.
no, really, no. Sometimes you want to ask questions that make people think.
For the structural, operational, class. Would that
Are you asking, should you know whether a pattern is creational or um, not? Or
be, yeah, and also even more important, whether it's listed as a class or object. Class, I think, compiles on
where does it list it as class pattern?
every single, at the very, very front of every, it'll say this is, or like for example, for adapter, class slash object structural. But then abstract factory is a class. A prototype is object.
And where are you seeing that? Huh.
Well,
Huh.
like, okay, it's like the title of, like the title of Abstract Factories, Object Creation.
Also, calculations and tabulated format. Adapter, and they say there's a one flavor for the object.
Yeah. But what does that mean? Class versus object.
I think it means
Yeah. And the adapter they show it composition of the object they are using. The same structure with the subclasses, they're saying it's structure.
Yeah, so in that pattern, I mean, the adapter is saying the class version is using inheritance to accomplish a task, right? Whereas on the object side, they're using composition.
Do we need to know which part?
What specifies it as a class pattern?
I'm not clear about structure or this.
So what are some examples of structure of object patterns versus class patterns? Yeah.
like I said, or like a decorator. I think it's just inheritance versus composition. Like decorator,
Right?
there's not as many class types. Template method is class.
Right.
Factory. I think it's the class one. Otherwise, I tend to class one.
So basically, what they're saying is that a class-based pattern uses inheritance to accomplish this task, right? Whereas object one, they're using composition. And so if you understand the basic idea of the pattern, it's easy to decide whether it's object or class, right? You know, deciding between structural and behaviorals can be a bit trickier. Um, right? Well, can you give an example?
An example would be like does not understand the pattern. It's a small understand what heritage the hero. I haven't seen.
Yeah, that doesn't understand will come up in the proxy pattern. Um, because you can actually use that to create a general purpose proxy to almost any object. But yeah, I mean, in those cases, worry about what's the idea behind the issue, not the actual language syntax, right? I mean, and if it's just weird C++ feature you need to worry about, or some weird Smalltalk issue, then yeah, we don't have to worry about that. But if there's some issue that's important, or some issue that we need to address, then that's a different story.
As far as patterns that use to strategy, obviously, eliminating if else.
Yeah.
Are there any other?
Yeah, null object is one, yeah. What's that? He said strategy, right? What's that? Interpreter, yeah. And we'll see later the visitor pattern. You know, perhaps not quite as strong a case, right? So what patterns use object-oriented recursion? Yeah, interpreter. Well, yeah, I guess. And the composite goes along with interpreter.
Decorators.
Yeah, decorator might work. I mean, they're mm,
What is the position? Like, it's just less
so the question is on the two design principles. One's programmed to an interface, not an implementation, right? What do you mean by implementation? So in Java, we can talk about collections, right? And so there's different types of collections: array lists, there's linked lists, right? There's vector. Um, those they're considered implementation. There's a list interface, right? Um, so what they're saying there is, look, it's more flexible to declare your variable to be of type list in Java than it is to declare a type array list, right? So if all your variables are typed array list, or your parameters are all type array list, you're programming to the implementation, right? The concrete thing you're going to get, as opposed to the abstraction, which is a list. Say that again,
Design
right? Well, so which patterns do you use program to interface?
the class and
Yeah, so does that mean that the adapter pattern does or does not use that strategy? Any other patterns which use program to interface? Composite?
Much abstract, that have an abstract, except that some of the abstracts that the real abstract class and stuff, they're pretty explicit about the exceptions where they say use an interface subclass, subclass unless specified.
So what patterns don't use program to interface? Template? Singleton?
Builder an abstraction.
Right? Well, the subject, right, is coupled to the observable interface, right?
Builder, they tell you to stuff things. Strategy.
Right. Right. Right.
We did talk about,
Right. Okay.
so is it like a concept?
So the question is, do other patterns use this concept of single and multiple dispatch? On the visitor pattern, yeah.
But the Python we talked about,
Yeah, we haven't talked about other patterns I can think of that we can use multiple dispatch on.
How would state pattern?
Um, so the state pattern, we want different behavior depending on what state we're in, right? And so the way the state pattern works is you have separate objects, right, for each different state. And then you ask them to do something. If you've got multiple dispatch, then what you can do is, instead of having a state object, we just have a state value, right? Or a state enum, right? And then that becomes part of the double dispatch. You write a function that depends upon the context and the state.
Is that we just have one context? We wouldn't have the type of or you have different.
Yeah, so that, my mind just comes up when you look at functional programming. So in object-oriented programming, the goal is, we have this object which contains a state inside, right? So in functional programming, um, they tend to separate out the functions from the state, from the data. And so where over here you've got an object and internally you have all the state, they say, well, just take all that state and represent it as a map, which really is what happens inside the object, right? It's just fields inside of an object are just conceptually like a mapping, right? Except it's hidden from the outside world. So they just say, just take that mapping out and put it over here as a standalone map, right? And then all these operations on your object, you just have functions, and you pass the state in, that map in. Basically, the way Python works, right? In Python, right? There's Python people. When you create a class and you have a method on it, right? The first argument is always what? No one does Python? Self, right? Why is that? Why do all methods and objects in Python, classes in Python always start with the argument self? Because someplace over here, there's the data structure they're going to pass into that method, right? And so they do that for you, right? And initially, when Python was created, that's how it was organized, is that there were structures and there were functions, and they faked classes by passing in that structure as a first argument to every method. So that's what the functional people do. They just have a function, right? And then you pass in this data structure, which in this case would be our context, right? But then if your context is a different state, then you can have another parameter being the type of state you're in. So here's your context map and your state map, and then you have a different function for each different type of state. Yeah, it's just for me, I'm trying to understand, right? So for several decades, object-oriented programming was like the thing, right? And now functional programming is on the ascendant, right? It's becoming more and more popular. But what's the difference? Yeah, so object-oriented programming, right? You put data structures inside objects and hide it, right? But when I use functional programming, I'm creating the same sort of structure that I did over here, except over here it's a map. And then what I'm doing is all the methods I put in the class here, or I put in a separate file over here. And so you say, no, there's this sort of natural correspondence going on. I can basically take this object and class over here and map it how I deal with it over here. And so then the question becomes, what about the patterns? What patterns, how do they map over? And as someone pointed out, right, when we're talking about implementation details, different languages provide different ways to do things or different obstacles, right, in the patterns. And so then the question becomes, when we go from objects to the functional, what happens when we try and map those patterns over here? And we'll see the visitor pattern is just basically getting around the fact that most languages don't have multiple dispatch. Whereas, some functional languages do, and so then we don't need the visitor pattern. Well, some people are not using Java, so I wouldn't ask a Java-specific question. I would ask how to do this in your language.
without variable that
So the question is, how is it that the memento pattern does not violate capitalization? Well, remember the memento supposedly is to be created so that only the originator can access the data inside. And so no one outside the originator can actually use a memento to access the data inside.
but what if I have after will it exception for error or it won't allow me
So the real question is, what happens when we're saving data memento and we then modify the class? That you need to deal with in your class when you
will it exception or like first place it won't allow me to use any of the class.
well, there are several questions there. So we're modifying the code and recompiling, right? So that means that we've saved an object somehow on disk, right? And so we save a memento object. Now, if you change a memento object, now you have to worry about versioning that and restoring that from a serialized version. And that's a whole Will it create a deep copy when you serialize something? If you want to make sure that you restore the entire state correctly, yes. But again, since you're talking about changing the class, that means you have to save that object in a serialized state someplace, right? And read it back in.
You wouldn't be able to save them on the disk anyway. Inside of it, it's a black. You can't see it. You can't save it. Put it back. Same object.
But it depends on what language you're talking about. In Java, you can create the mental class so it can save itself in serialized state and read itself back in. You can also do it in a binary format to make it harder for anyone else to read it. In Python and Smalltalk, it's hard. You have to go all your way to make sure it's not serialized. Well, I think in Python you can just mark it as not serializable or markable, right? Anyone? All the Python people? Any Python person serialize Python object? But whenever you're serializing and deserializing, if you change that class, you have to worry about that versioning when you deserialize it. Inside the originator, if the mental class hasn't changed, you're just saying, give me this, that, give me that, right? So it doesn't matter whether or not. If the mental class hasn't changed, then you interacted the same way, right? The difficulty becomes, what happens when your originator has a new field which it had before, right? The mental doesn't have it. Now what do you do?
Then what happens?
What happens if you serialize the object? Try to restore?
What happens? You have to write code to deserialize it, and normally what you have to do, you do versioning, and so then you code like you read a version number, and then
So worst case scenario, then it was missing some data.
yeah, and then you have to figure out what a default value is. Well, if there's no good default, you can throw an exception and.
The purpose of the pattern. Bring back later.
Yeah, but again, it depends upon how you're using the pattern, right?
Not serial.
Not necessarily, no.
Typically serialize. Not serialize the originator, bring back the originator
Yeah,
directly.
right, yeah.
Not serialize the memento.
But if you're using a mental pattern to do undo, and you want the undo to survive execution of the program, right? Then you would serialize mementos and utilize them.
In that case, more robust.
Yeah, but again, it depends on the situation, right? Yeah. Well, that paper had several purposes. One was just to point out that in general, people don't talk about disasters and things. I mean, it was like all the literature says, here's all the great things we can do, and then in reality, everything's always a mess, right? So it's like pointing out, I mean, everything you say is all this great stuff, but everything's really a mess. So what's going on here? Um, so part of it is just like this is our reality, and if we don't acknowledge our reality, we can't change it. We can't improve upon it. So it makes you more aware of what's happening in the world, right? And hopefully you can avoid some of the problems.
But in real life, um,
Yeah, 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 yeah. Sweep it under the rug pattern can be considered to be sort of a scaled up version of the adapter pattern, right? All this stuff no one understands anymore, and we read it, so we just wrap it up in another class or system of classes, and now we talk to that instead of. I guess your Python's famous for having an interface to C code, right? So you can say Python uses adapter pattern all the time when you're dealing with underlying C code, and we just write a Python adapter to that C code, and now we can use the C code instead of having to write C code.
after having given the
Well, what pattern would you consider? I mean, the C interface has a fixed interface, right? But we don't want to use that interface. We want to use a Python interface to it.
tree structure. Can't imagine.
Well, a file system has what? And there's text files and binary files. And hmm
So after we start parallel, we add one.
yeah, the question is, yeah, on the builder pattern, why do we ask the concrete builder to give us the object instead of the director? Um, because different builders could return different types of objects for the concrete. And so this way the director doesn't have to worry about what type of object should it return.
But when we told the director what kind of object,
Yeah, I mean, so that, remember that we have, the director knows, various operations we're going to use to build something, but end result, there could be different types of object. It could be an XML object, it could be HTML object, it could be all kinds of different things, right?
so they just
Right, not the actual type, yeah. Right, it could be a PDF document, it could be all kinds of things. Um,
Functions that
mm.
like objects.
So the question is the functor pattern. Um, originally they talked about it in the context of, like in C++, or Java, where Java you couldn't have functions, right? So you had these objects would only had one method that did one thing, right? But we could do that in C++ with a function, and so that function could replace, what we use this object for. Now, lambdas give us more functionality towards that regard because we can actually give lambdas state that it recalls, right? Remember, so lambda is actually probably a better example of a function acting like an object than a function in C or C++.
Yes.
Yeah, so functions go away now. Because that's the thing.
Right, yeah.
I don't think that.
Well, I wouldn't go that far because there's a lot of languages out there.
C++ and Java. Now having Lambda.
Yeah, I mean, it's our world continually changes, yeah.
Serialized.
Yeah.
We don't have
Some, yeah.
to say something. Also, one of the code smells that they were saying that it must have been from Python. Private. Kind of sneaky.
Yeah, there's definitely a different philosophy among the Python people, right? C++ and Java have this very lockdown mentality of, different levels of private access, where Python's like, everything is public. And even your private thing, that's all by convention anyway, so you can still access it.
But is Python's different philosophies that they programming?
No, I don't think so. Python was created late 80s, early 90s. It came out before Java did. Yeah, Python's a really old language. And, just Guido we're just not happy with the languages that were out there, and he wanted something flexible and easy to use. And small talk. Um, all the methods are public. Again, they have a convention that you can market as private, but again, it's a convention. You can violate that whenever you want. Yeah. Now your fields or properties are all private. You can't make them public. Well, you have to separate encapsulation with information hiding, right? Python, you can encapsulate things in a class. There's no information hiding because the entire structure is available public. So yeah, there's encapsulation in Python, but there's no information hiding.
Information having what you're saying, the design might change.
Right.
But
Right.
encapsulation.
No, encapsulation is just putting things in a container, right? No, it's useful, so you don't need to know it. It's useful, so you don't need to know it. No.
What is that? You say like the class, the guys that
But in the template method, the interface object hasn't changed at all, right? The adapter pattern, decorator pattern. But when we're talking about changing the guts, right, things like the state pattern, right, the strategy, you're actually changing what's inside the object. Changing the skin means you're putting something around it, right? Yeah, you're not changing the inside of the object, you're changing the outside of the object, right? Was that? Proxy being the other one, yeah. Yeah.
She just said decorator to add methods. That's not what she's decorating.
No. Add responsibility.
You do it by the same interface.
Yeah, so
Making it
that might be
extra things.
that may not be the best example of changing the skin, right? Adapters are much better.
Decorator changes the skin. Kind of scroll
Right, right.
That was another chain of response. The chain of response drop,
Mm-hmm.
and so every step, normally chain of response is fast. In this case, every step of the chain of responsibility is actually translating the
Right.
coordinates.
Mm-hmm.
That's kind of interesting.
Right. Right.
For chain of responsibility, is that weird to me how every chain in the link has to know?
Mm-hmm.
Is that ever?
What do you mean by external?
You have one object that contains a list maybe
Mm.
of all.
I don't know of an example, but that doesn't Um, well, there are times when things may not get handled, right? The help example, I mean, you request for help and it goes up the chain and it comes out the end and we can't help you, right? Don't know the answer.
In the book, they talk about it. To me, that's the bug.
Right, yeah. It is just a bug, right? Well, we'll see everyone on Thursday. You don't need to bring any answer books. I always leave room on the exam to write the answers on the exam.
So with that,
You don't need an answer books.
we don't even.
No.
Oh, okay. Yeah,
Yeah.
it's just your hands paper, we write on it.
I give you paper and you write on it. Correct. Yes.